Explain one difference between a digital and analog signal. It's 2 marks, but I don't understand the explain part. But analog, stop it. Analog is continuous, and digital is discrete. To show what other words to say. State 2 examples of each of the following: wired transmission medium, wireless transmission medium, wired coax. Sorry?
Nothing.
You left. Nice.
Yeah, I went to fix it. But I'm here.
Yeah. Coaxial, twisted pair, and fiber optic. Those are all wired. Wireless will be microwave, infrared. Yeah, that's all. Microwave, infrared, Bluetooth for wireless transmission. Remember, Wi-Fi is not a transmission medium. Wi-Fi is really microwaves. So, just in case you put Wi-Fi by mistake, thinking that Wi-Fi is transmission. Alright, using examples, explain the client-server model of computing. Such a nice question. These module 3 questions will be, nice. A central server would contain all the information that the clients on the network would need and the clients send requests to the server for information. Example, websites. Using HTTP for web pages. Yeah. Alright, explain using examples. Right, so client server. The server is where the clients basically have to request things from the server all the time, and that will make life easier. Alright, the College of Inquiry has decided to install a local area network to be used for both staff and students. It's expected that both groups will connect to the internet to do research and communicate with stakeholders external to the college from different points in the campus. It is also expected that the college will connect its LAN to other LANs. Alright, 4 network devices. So we have some key here. We know that LANs have to connect to other LANs. So that means they had to have some sort of bridge. Definitely. Both groups will connect to the internet. So when you're connecting to the internet, you definitely know you need a modem. You need a modem for sure. It's to be used for both staff and students. That means you have 2 different sets of people that you need to serve. So you would need a router. And they have to communicate with stakeholders external to the college. So they will have to have some sort of device that will be necessary to do that, which will most likely be like a firewall. Alright, so they would need a modem. Why? To connect to the internet. They would need a router to route packets to staff and students. They would need a bridge to connect the LANs to each other, and they would need a switch switch to send data put data send data throughout the network. Cool. Yeah, that's basically it. Alright, describe how two types of transmission media can be used by the college. So they could use wired to connect all the desktop computers in the buildings, and wireless to allow for mobile access to the internet by users. So wired will connect all that. So I'll put example twisted pair, and then for wireless I'll put example Wi-Fi. Alright, state 3 ways in which different users may be granted access to the various data and resources on the network. Passwords, and the usernames. So usernames and passwords, lock words, or firewall, or encryption, or access control list. Access control list. Yeah. I don't think you will get firewall. Although in a firewall you do block access to various data and resources. Yeah, you are correct. Encryption, you will get encryption. Encryption doesn't necessarily block anything on the network. So usernames and passwords, access controllers, firewall, and lock words. Those are the things that the syllabus has. Yeah. Right? That should be it there. I have so much space and I need to write and I'll space up everything there. Okay. Next time for sure. Alright, so that is that. So what we'll do is you could do number 6 and the 2012 module 1 for next week. Is that a manageable goal? Bunch of Eagers, militaries, just support the people. Alright, distinguish between batch processing and multi. Alright, this question kind of stupid. Based on my remembrance of it. But we will put our best foot forward. To distinguish between the two of them, it requires a little bit of understanding of how both of them work. But how both of them work is not as straightforward as just taking it from the notes. You gotta kind of be able to grasp a little bit of the inner workings of what takes place. Right, candidates who are often unable to properly or clearly distinguish between a batch processing system and a multi-user system. For example, some candidates stated that a batch processing system only one user uses the system at a time. The examples provided were often not representative of the type of system. But they didn't really say what they want now. So what you have to kind of think of is, in a batch processing system, the whole program runs from start to finish. In a multi-user system, multiple people could put their programs in and they get a certain amount of time. So in batch, all the code in the program must be run before another program can be run. Alright, so the 2 marks inside there would be that all the program has to be run and then another program gets to run after. Batch processing means you have to do the program in batches, one after the other. In multi-user, the programs are sent and each one is given a set amount of processor time to run. Thus, multiple users can get programs executed. Over the years, doing this question, a lot of children kind of mess it up, because when it says to distinguish between, a lot of the times is when you get like 2 mark answers. It'd be like one runs a program from start to finish and the other one multiple users could run the program. But you had to be able to talk about the actual processing that takes place. If you could throw in words like round robin, that would kind of help the situation, or last in first out, or first in first out, something like that. In batch processing, you would have a lot of like life 1, 5, 4. But with multi-user, you would have a lot of round robin. The example for last in first out and round robin might help a lot. Alright, so name one application for which batch processing systems are used. That's usually things that you have to run like large processes for, which would be like payroll generation, also what's the other one by? Anything you have to generate large files, generating accounting files, balance sheets. Right, so that'll all be done in one batch, and they will put it in, and then there'll be a big end product. So anything that is there, something that goes in and you get a big end product, batch processing. Alright, one application for which a multi-user system would be appropriate, that would be for like mathematical calculations. So each person will get like their calculation will be done and then sent back to them when somebody else would have a calculation. Or point of sale transactions. So you get your transaction done, they give you back an answer. If it gets a next transaction, they give you back an answer, next answer, next answer, next answer. Those will be simple multi-users. And multi-user systems, they're kind of straightforward in terms of multi-user systems. You can think of almost any system that we have right now where you have multiple little things that could get done piece by piece and then give you an answer. Alright, describe 2 ways in which files could be protected. Alright, so these are kind of straightforward, which will be usernames and the passwords can restrict access to files. Encryption can scramble the file so that it is not readable without a key. Yeah, usernames and passwords encryptions, those are your go-to answers. There's another thing in the syllabus called lock words, which is basically a phrase that you use to lock that particular file. I don't really like that answer because usernames and passwords exist, but yeah.
What's the difference?
A lock word is like you don't need a username to be the starting point. All you have to do is just put in the key phrase and it will unlock it. Yeah. Alright, a program is currently running, needs to retrieve data from a disk, so an interrupt is needed. An interrupt is I think this best word will be a signal. A signal that is sent to a signal sent to the processor indicating it should stop and deal with a pending process. Yeah, basically, something like that. Briefly describe how an interrupt is handled by the processor. Alright, well, whole 3 marks. Okay, the processor would be signaled the current process would be stopped and put in a either waiting or blocked state. The new process will be run to completion. Then the previous process starts back. Something like that. Basically, the 3 marks I want to put would be that, the current one is stopped, the new one will go in and run to completion, and then the previous process I was running will get to come back inside. It's kind of like yeah, I gave you all enough analogies on that already. I think you should be okay. No questions about that, right? Okay, wonderful. The diagram below depicts a difficulty. This difficulty is called a deadlock. Ta-da! Right here. Outline the conditions under which this event will occur. Deadlock is very easy to explain. Process A has resource 1. Process B has resource 2. And then process A wants resource 2, but process B won't let go until resource 1 is also deadlock. Yeah, straightforward explanation there. Once you could show that both processes have one thing, and then 2 marks for showing that both processes have each other's stuff, and the next mark is they won't let go until the other does let go. So explain 2 ways which difficulty could be resolved. Way number 1 is kill one of the processes so that the resource becomes available and process. And the second way would be to, what is the second way though? Is there a second way? I don't know of a second way to end a deadlock. This is a valid answer. Preempt one of the processes, a third party process, so that the resource being held is set free. Hashtag, yes, set free. Briefly explain how the round robin algorithm works. Alright, so round robin 1. A process is given a time slot. The process runs for a given time, for the given time. That's what I want to say. For the given time. It goes into waiting until its time is up. Hashtag all might. Alright, cool. 1, 2, 3. Goes into waiting until its time is up. Ta-da! Alright, cool.